Reloaded.
There they are.
One enemy remaining. Flawless.
They were blind.
You say something? Sorry, ear's still ringing.
Let's start this party.
Wall raised.
Prepare for hellfire!
Enemy spotted B. Enemy spotted B.
Jets grounded.
Spike planted.
Satchel
No
up.
more cage trigger. Shock dart. Shock dart.
Enemy spotted B.
Reloading.
Thanks to NordVPN for sponsoring today's video. Europa,
One enemy remaining.
one of the most exciting moons in the entire solar system. It is a beautiful world filled with mysteries. This is the first ever close-up image of Europa, taken by the Pioneer probe back in
Last player
1973.
standing.
Since then, we've had the Voyager and Galileo probes explore the moon, and with each visit, Europa has never failed to surprise us. We are yet to solve a lot of Europa's puzzles, but there are many things that we are starting to piece together. I'm Alex McColgan, and you're watching Astrum. Stick with me in this video, and together we will explore some of those fascinating mysteries and delve into almost everything there is to know about this intriguing world. Let's first of all see where Europa fits into the Jovian system. Europa is the second and smallest of the 4 Galilean moons, although it's still the 6th biggest moon in the entire solar system, just behind Earth's moon, with a diameter of about 3,000 kilometers. It takes Europa 3.5 days to orbit Jupiter once. Interestingly, the first 3 Galilean moons, Io, Europa, and Ganymede, are locked in a 4-2-1 orbital resonance due to their gravitational influence with each other. This means that every time Ganymede orbits Jupiter once,
Camera taken out.
Europa orbits twice, and Io
Cage
orbits
triggered.
4 times. This orbital resonance and the constant gravitational tugging from the other moons keeps the orbit of Europa
Spike
from
planted.
ever becoming completely circular. Due to Europa's slight elliptical orbit, the magnitude of the gravitational force acting on it
Last
from
player
Jupiter
standing.
increases
One
and
enemy
decreases as it orbits. This creates tides that stretch the moon's surface. These forces are significant as they have a big influence on the moon's appearance and what goes on under the surface. Europa's surface is made predominantly of water ice. As you can tell, it looks very remarkable and distinctive due to these long, continuous fractures and cracks. These are called lineae, which translates to lines in Latin. These lineae are often only about 1 to 2 kilometers wide, but can extend for thousands of kilometers across the moon's surface. We aren't sure how or why these lineae are formed at present, but the most likely theory is that as the crust pulls apart from tidal flexing, warmer material from beneath fills the gap, in a similar fashion to the ocean ridges on Earth. In this image taken by the Galileo spacecraft, you will notice some dark brown spots. They are very small, only about 10 kilometers across, and they are known as lenticulae. They are also believed to be formed by the upwelling of hot, less dense material to the surface, either by pushing the existing crust up or by breaking through altogether. Should the underground material have broken through, what we can then see are these strange, unusual terrains called chaos terrains. They are really rough patches surrounded by a rather smooth surface. These spots are expected to be soft and may
Last
contain
player
significant
standing.
information about what's under Europa's surface, which we will get to later in the video. Data from Galileo also indicated that Europa's equator
them
may
try
be
to
covered
get
in
through.
icy spikes called penitentes. These vertical cracks may be up to 15 meters high and will have formed from direct overhead sunlight on the equator. Interestingly, penitentes are found on Earth too, in dry regions at high altitudes, although nowhere near as large as on Europa. Despite being roughly the age of the solar system, Europa barely has any craters. Europa has less than 50 major craters, whereas the Earth's moon has more than 5,000 craters with a diameter above 25 kilometers. This indicates that Europa's surface is constantly changing and reforming. Models suggest that Europa's surface is only about 30 to 180 million years old, which is very young in geological terms. Additionally, Europa's icy surface is the smoothest surface of any known solid celestial object in the entire solar system. Its icy crust also has an albedo or light reflectivity of 0.64, one of the highest of all the moons. Europa's albedo makes it 5 times brighter than our moon.
So what I mean?
The surface is bombarded by a constant and intense blast of radiation from Jupiter. The radiation level at the surface of Europa is equivalent to a dose of about 5,400 millisieverts per day. Exposure to radiation at that level would be enough to kill a human in a single day. The reddish-brown color spread across the cracks and fractures of the moon is believed to be due to salt and sulfur compounds mixing with water
30
ice
seconds left.
and then modified by Jupiter's radiation. A recent study from JPL suggests that Europa might even glow in the dark.
Here.
Energetic ions from the radiation penetrates the surface, which would energize the molecules beneath, which would make them release energy as visible light.
10 seconds left.
Unfortunately, we cannot see Europa's dark side from Earth, as we are between it and the Sun always. So we are going to have to wait for future missions to Europa before we can prove this. Radiation received from Jupiter plays a
Last player
significant
standing.
role in Europa's atmosphere
Last
as well.
round in the half.
Europa has a very tenuous atmosphere, composed primarily of oxygen. Unlike on Earth, the oxygen on Europa is formed by radiolysis, or in other words, the process of radiation bombarding the water ice surface, separating the H2O into oxygen and hydrogen. Hydrogen escapes Europa's gravity altogether because it's so light, whereas a lot of the heavier molecular oxygen remains. The hydrogen and oxygen that escape Europa's gravity form a dispersed neutral cloud, which follows the orbit of Europa around Jupiter. In 2012, the Hubble Space Telescope discovered plumes of water vapor erupting from Europa's south pole.
Get out of my way!
This image suggests that the water plumes rise up to 200 kilometers from its surface. In 2018, astronomers found additional evidence of water plume activity on Europa when they looked back at the old Galileo data with a new data analysis technique. A dedicated mission studying these plumes can also help us understand what's inside the moon without having to land on it.
Spike planted.
Because what may lie underneath that solid ice surface is perhaps the most fascinating thing about Europa. There is likely to be a global ocean between a rocky mantle and the water ice crust. The first clue that this amazing ocean world was hidden under its surface was provided by the Voyager and Galileo probes in 1979 and the late 1990s respectively. Between these missions, there was a drastic change in the magnetic field of the moon, which is not possible unless there is some electrically conductive fluid beneath its surface. Europa's crust also indicates the presence of a liquid layer beneath it, as it rotates with an angle of 80 degrees, which is not possible if the crust and rocky mantle were mechanically attached. Instead, it is likely that the icy crust floats
Switching
on the
sides.
ocean, and it is believed to make one full rotation around the moon once every 12,000 years. The fact that this ocean is not attached
here.